continuing the Algebra 2 spring semester exam review, and we are here on the second page with the section that says solve the following involving square roots. Okay, so I talked about in the last video at the beginning of the review, quadratics was unit 6 and 7. Okay, so if you need to go back and look at any notes, quadratics was 6 and 7. Square roots was unit 8. So if you are struggling as we go through square roots, you need a little refresher, you want to look back at your notes, square roots is unit 8. Okay, so when we are asked to solve, and I said this in the last video when we were solving quadratics, if you are asked to solve, what is it you're finding? Does anybody know? Graphically, what it is if you are solving, you're finding a solution, what does that mean? What is solution the same as? It's another word for that. X-intercepts. So we are finding the x-intercepts. So when you're told to solve an equation, it doesn't matter if it's quadratic or square root or log or exponential or rational, any type of function we've worked with. Solve, get your solutions. Solutions is another word for x-intercepts, roots, zeros. Okay, so x-intercepts, we could solve all of these graphically. Okay, I'm going to do a couple by hand to refresh your memory, but you can solve by looking at the graph and seeing where it crosses the x-intercept. Okay, now, to find your x-intercepts graphically, you do need your equation set equal to 0. Okay, so if doing it graphically and looking for the x-intercepts, you need the equation set equal to 0. Put it in your calculator and you can find the x-intercepts. So that's one option. Okay. Now I'll show you some other options if it's not set equal to 0 on what you can do. Okay. But sometimes if it's pretty basic, it's not hard to solve by hand. Okay. Hopefully you remember that a 1/2 power, when you have a fraction, that's the same as a radical. So the denominator is the radical. So 1/2 means a square root. So this means the square root of x equals 2. A lot of y'all can do that in your head. The square root of what is 2? 4. Your answer is 4. Okay, but if you don't know that off the top of your head, let's just use our algebraic skills. To get rid of a square root, what would be the opposite operation? If I'm trying to solve this for x, how do I get rid of that radical? The opposite of square root is square. So I could square both sides. What you do to one side, you do to the other. That would get rid of the square root there. And 2 squared is 4. So yes, some of them are very basic and it's probably quicker to just do the algebraic steps if you know what you're doing. That's faster than going through probably and pulling up Desmos and getting it all typed in. Okay, some of them are more complicated. Okay, and so graphing may be your best bet. Okay, let's look at B. Okay, if I want to solve algebraically like I did this one, I need to isolate the radical term, the square root. So I need to get this square root by itself. So first I would subtract the 3 over. And then I would divide out the 2. Now I've isolated the radical. Now I can square both sides just like I did in part A. So I'm going to square both sides. Okay, and 4 squared, 4 times 4 is 16. And then it's just a basic algebra problem I finished solving. So I add the 1, 3x equals 17, and divide by the 3. So x is 17/3. Okay, now, when we are solving with square root functions, when you're raising both sides to a power to solve, you can sometimes create extraneous solutions. So we talked about Originally, when we did this unit, we talked about how you need to check for extraneous solutions. So you can do that in Desmos. Okay, so I could simply plug in the 17/3 up here and make sure it works, or I could check this graphically. What I was saying before is if it's finding your x-intercepts, you need to graph it with the equation equal to 0. If I wanted that equation, that original equation, to equal 0, how would I have moved that 11 to the other side? Instead of moving the 3 to the right, what if I moved the 11 to the left? So it was just 0 on the right. How would I move that 11 to the left? I would have subtracted it. So I could write the entire left side. So 2 square root of 3x minus 1. And then it was what? Plus 3. And then subtracted the 11 over and just so typed minus 11. I don't even have to combine the like terms. I can type it like that. And it gives me a visual of the graph. Okay, I can see this is the function and I'm looking for the x-intercept. And that's the x-intercept. Now we got 17/3 as our answer. I'm not sure what that is as a decimal. So let's see, 17/3. Is that the same thing that it's showing here? You'll see that? You get the same answer. So had this been a multiple, it's a great way for me to check my answer, okay? But if it was a multiple choice question and I had 17/3 and 3 other answer choices, I could just type all of them in and see what they are as decimals and see which one matches this x-intercept. Okay, for a lot of you, that's going to be the easier route. And that's fine. Okay, so I came here to check to make sure that that was a solution because it's possible to get extraneous solutions. But if you had answer choices, you can always just plug those in and make sure that they're the same. If I wanted to, I could have solved the first one like this as well. I could have said x to the 1/2 power. Okay, and then to move that 2 to the other side, I would have done minus 2. And I could have looked at that graph and seen that the answer is 4. The x-intercept's 4. And that's what I got algebraically. Okay, so let's try solving this one just with Desmos. So if I were to get this set equal to 0, I would have the left side, which is 4x squared. And then whatever's on the right, I would have to move over. So I would minus 64. So this is the equation set equal to 0, and I can see my solutions are at -4 and +4. So I don't even have to do it. I guess I did have to do a little bit of algebra. I had to subtract the 64 over this way so that I had it like this in Desmos. Whoa. And I looked at the Desmos graph. Okay, I had to get it set equal to 0 to look at the Desmos graph, but then I can see my answers are at -4 and +4. Now, your other option, instead of moving everything to one side and getting it set equal to 0, your other option for solving with Desmos is, what if you leave it like it's written? Okay, you leave the left side and the right side alone and you write them as two separate equations. So you write the left side and then I write the right side. Now, I'm writing them as two separate functions. So I'm going to put y equals the left side and y equals the right side. And then I'm going to look for where they intersect. I had to zoom out to see that because 64 is up there pretty high. Okay, but look at the x value of those intersections. What is it? -4 and +4, right? It's the same solutions we got here. So you can either get it set equal to 0 and you'll see the actual graph of the function and you can find the x-intercepts. Or you can do the left side as an equation, y equals the left side, and y equals the right side, and look for the intersection. Okay, so let's do that with f, and I'm going to write that down. Okay. Why is this not working? Oh, my pen stopped working all of a sudden. It always wants to do this only when I'm recording, of course. Give it a little battery, a little break. Okay, here we go. Okay, so or in Desmos, instead of setting equal to 0 and going in Desmos, you can do y equals the left and y equals the right, and find the intersection. Okay, so these are your two options for solving this in Desmos, and I'm going to highlight here. Okay, so you can set equal to 0 and look at the Desmos graph and find your x-intercepts. Or in Desmos, you can set y equals the left side, y equals the right side, and find where they intersect. Okay, so that's what I'm going to do here on that one. So the left side is 2 times x minus 2 squared minus 3. And the right side is 159. Now I'm looking for the intersection. I had to zoom out because 159 is way up there. Okay, but now I'm going to look for the x value of that intersection. That's at -7 and 11. And I have my solutions. It's easy enough, right? So if y'all understand how to use Desmos, these questions aren't too tough at all. Let's do that with D. Okay, the left side is the square root of 2x plus 4. And the right side is the square root of x plus 2. Because we're looking for where those are equal, so we can graph them separately and see where they intersect. Okay, where are these two equal to each other? Okay, and it looks to be like the starting point there. Looks like it's at -2. Okay, now your other option, besides looking to see where they intersect, was to move everything to one side. Okay, so I have the left side, and then I could just subtract that term from the right over to the left. So then I would have minus the square root of x plus 2. And I would just look at that graph, and I can see the x-intercept is at -2. So both ways, getting it all to one side set equal to 0, or doing y equals the left, y equals the right, and looking for the intersection, both of them gave me the x value of -2. Okay, so in Desmos, I'm able to solve these. Okay, so let's see. Let's do, this is the square root of x minus 6. And then that -2 on the right, to move it to the left, I would have to add 2. So it would be plus 2 if I wanted to set it equal to 0. And then I'm looking for the x-intercept. So here, that's at 16. So x equals 16. Or I could have done this separately I could have done y equals the left and y equals the right and found the point where they intersect, which guess what, is also where x is 16. Good? All right, so let's see what's next. That was square roots. All right, rational. This is the most recent thing that should be on your brain because this was unit 12. This is what we most recently tested on just last week. So simplifying rational expressions. We talked about, you can look back at your unit 12 notes. We talked about add, subtract, multiply, divide, rational expressions. And then we did solving rational equations. Okay, but when we are simplifying rational expressions, remember when you're trying to get everything in factored form and reduce what you can, any common factors, once you get it for multiplication and division, or in addition, once you have them combined with a common denominator. Okay, but I also showed you in those lessons how to check it in Desmos, how you can again see if the original way that it's written matches that graph, whatever this would graph should be exactly the same as this, what the simplified version would graph. And because your test is multiple choice, it will simply be type this in as you see it. You'll get a graph. And on another line, type in answer choice A. If it is the exact same graph, that's it. If it's not, try answer choice B. And try your answer choices until you find the one that is the exact same graph. Okay, so again, work backward from your answer choices, especially for rationals. Rationals are pretty complex. It's a lot faster with a multiple choice test to just work backward from your answer choices. Now, obviously, this review is not multiple choice, so I can't do that. I can use it at the end to check our solution. Okay, now, to actually solve this, I want everything factored. Okay, so I'm going to factor my numerator first, and then factor my denominator. I've got the x squared already factored out, but then I'm going to factor the rest of that trinomial in the denominator, and then that's being multiplied by 6x squared, which is over nothing. It's over an understood 1, if you want to put that. Okay, so in the numerator, x squared will factor to x times x. Factors of negative 12. First of all, negative means there's going to be one positive and one negative. So the factors of 12 whose difference is 4. That would be 6 and 2. Positive 6 and negative 2 would combine to give us positive 4. In the denominator, it's a positive, so I know they're both going to be plus. So the factors of 18 that add to 9 would be 6 and 3. So now I've got everything factored, and I can reduce common factors from the numerator and denominator. So first of all, I see that x plus 6, so that gets to reduce. I see x squared here, so x squared in the denominator and up here in the numerator. Okay, and that's it. That's all I see. So that's going to leave me with 6 times x minus 2 over x plus 3. And that's as much as I can reduce it. Now, what I'm talking about in Desmos, let's say this was multiple choice and this is one of your answer choices and you're trying to check it. Okay, so you can type in the original expression. Again, I would type the division first so you get your numerator and denominator. So I've got x squared plus 4x minus 12 over x squared times x squared plus 9x plus 18. Oops, that's supposed to be a plus. Okay, and that's being multiplied by 6x squared. Okay, so that's the way that it was given. And you can see the graph here, this rational function. Okay, now let's type in our simplified version. Okay, or let's pretend this was multiple choice and I'm typing in answer choice A. I've got 6 times x minus 2 over x plus 3. And look at, oops, I again typed a equal. There we go. I can turn that graph on and off and see underneath it. It's the exact same graph. That's what you're looking for, is that it's the identical graph, because a simplified expression should be equivalent to the original. You didn't change the value of anything, you just reduced, you simplified. They are equal to each other. They should graph exactly the same. Okay, so you can check those graphically from your answer choices. That's probably one of the best routes to go. So here in F, I've got nothing to factor, but I've got several things to reduce. So the 12 over 6, that will reduce. 12 divided by 6 is just a 2. Okay, and then the x squared over x cubed. Okay, so that's 2 x's on top, x times x, and 3 x's on bottom, x times x times x. So the 2 x's on top will reduce with 2 of the x's on bottom and leave you with just 1 x on the bottom. X cubed over x squared, or excuse me, y cubed over y squared. So it's going to get rid of all the y's on the bottom. You'll be left with 1 in the top. Okay, and then the z's, you've got 1 up top and 2 at the bottom. So it's going to get rid of all of them from the top and just 1 of them from the bottom. So you'll be left with 2y in the numerator and xz in the denominator. That's as far as you could take that. All right, with B, I need to see if I can factor, which I can. I've got some GCFs of each of those that I could take out. So in this numerator on the left, I could factor out a 3, and that would leave me with x squared minus 4. And in my denominator, I could factor out a 5, and that would leave me with x minus 2. And here I could factor out a 2, and that would leave me with x plus 2. Now, that numerator, x squared minus 4 right there, that can actually be factored further because it's a difference of 2 squares. So instead of x squared minus 4, that becomes x plus 2, x minus 2. So I'm going to go ahead and mark that out. I factored it further. Now I'm going to see if I can reduce, which I see an x plus 2 in the numerator and denominator, and I see an x minus 2 in the numerator and denominator. Okay, so those will all reduce and leave me simply with 3 over 10. Now, when you are dividing, like in G over here, remember you keep, flip, change. So you keep the numerator and denominator as they are for the first one. We do factor though. So that is going to be an x squared that will factor out of there and leave me with x plus 3. Now, keep change means change the division to multiplication. And then flip means I flip this numerator and denominator. So what was in the denominator is now in the numerator. And what was in the numerator is now in the denominator, but I'm going to factor it. So that's going to factor. Factors of 6 that add to 5 would be 3 and 2. And now I see if I can reduce. And I see here an x plus 3 in both. And then I've got an x here that can reduce with one of these x's, so that just won't be squared anymore. And that's all I can do. So I am left in the numerator. I've got an x and then an x cubed. So I've got 5x to the 4th. And then in the denominator, I've got 2 times x plus 2. All right, C is multiplication, so I don't need to move anything, but I do need to see if anything can factor, which in the numerator it can, because this is a difference of 2 squares, so that's x plus 2, x minus 2. But the denominator, x squared plus 4, that does not factor. Okay, it's only difference of 2 squares that factors. So then when I go to try to reduce here, I can see that the x minus 2 will reduce, but the x plus 2, those are both in the numerator. So that does not reduce. So we have x plus 2, and you can write x plus 2 again, or you can just put a squared on it like that, because there's two of them. There's two of those factors in the numerator. And in the denominator, we have x squared plus 4. And some people are going to try and say, well, isn't that what that is? If you square the x and square the 4, that's not how that power works when there's a plus or a minus sign in here. You only distribute the power if these terms are all being multiplied. But because of that addition sign, this means actually squaring means multiplying it by itself. So you would have to do x plus 2 times x plus 2, and you would do your double distribution. It is not the same as this, okay? So that's as far as we can take it. All right, another division here in H. So we're going to keep, change, flip, but I'm going to factor. So the numerator on the left, the factors of negative 20 that add to positive 1 would be positive 5 and negative 4. The denominator is x plus 1. Change from division to multiplication and flip the numerator and denominator of this one. And an 11 can be factored out to leave me with x plus 5. So then I see, can I reduce? And I can. I've got x plus 5 in both numerator and denominator, and I've got x plus 1 in both numerator and denominator. So I am simply left with x minus 4 over 11. All right, in D, we've got to factor again. There's a lot of practice on these. So I'm going to factor out that 5, and that's going to leave me with x squared minus 4, which again is a difference of squares. So that's going to factor to x plus 2, x minus 2. And then my denominator is just 25x squared. And then this one doesn't factor at all. But now it's time to see what will reduce. X minus 2 will. Okay, this x up here will reduce with one of the x's here, so that's not squared anymore. And the 5 over 25 will reduce to 1/4. So that leaves me with x plus 2 over 4x. Another division. So I'm going to keep but factor. Change to multiplication and flip this one, but factor. So that factors to the x plus 2, x minus 2 again. And this factors to plus 3 plus 2. So then I'm seeing what will reduce here, x plus 2 and x plus 3. So that simply leaves me with x plus 1 over x minus 2. And again, for all of these, if these had been multiple choice, you can just be plugging the original way that it's written in and the options of the answer choices and see which graph is exactly the same. Now, when I'll do one of these real fast in Desmos, because the division ones, that division symbol that we're seeing, the way that it's written, that's not in Desmos. For the division symbol, you actually have to type divided. So it ends up being kind of messy looking. So this divided is this division symbol. So you have to have a fraction in a fraction. So you're going to have x squared plus 5x plus 6 over x plus 3 over, because it's divided by, and then it's x squared minus 4 over x plus 1. So that's what that ends up looking like, real messy. Okay, so a rational divided by another rational. Now type in our answer choice that, or what we came up with, or in the test, this would be an answer choice because it's going to be multiple choice. And you can see those are the exact same graph. Okay, so the division ones look a little messy when we graph them in Desmos. Okay, but you can still work backward from your answer choices to check these. All right, in this last multiplication one, I'm going to factor this one on the left, and it's understood to be over 1 if you want to write that. Let's see, the factors of negative 30 that add to 1 would be positive 6 and negative 5. And here there's a GCF of x that would leave us with x plus 6. And so we can see that that would reduce the x plus 6 and the x. So you'd simply be left with x minus 5. You don't have to put over 1. There's nothing else left in the denominator. It's an understood 1. All right, over here, we're going to keep the numerator and denominator of the first ones where they are, but we're going to factor. And then we're going to change the sign and then flip the second. There's no factoring in this one. All right, so here this is going to factor. The only factors of 7 are 7 and 1. And we want it to multiply to a negative, but add to a positive. So we want positive 7 and negative 1. So then when I go to reduce, it's the x plus 7 that will reduce. And then this 6 and 3 will reduce. 6 over 3 is just 2. And then one of the x's from the denominator will eliminate that x in the numerator. So we're left in the numerator with 2x minus 1. And in the denominator, we're left with just that single x. So it's a lot of factoring and reducing for multiplying and dividing rational expressions. But again, your test is multiple choice. Type in the way that it is originally given, type in your answer choices, and see which one's graph is exactly the same. That's all you have to do. All right, here we're simplifying rationals, but these are addition. So it's not multiply and divide, it's add and subtract. So when we look at these, we have to get common denominators. Now, again, these are going to look more complex as I'm doing them algebraically, but you get Desmos. Work backward, type the way that it's originally written, type your answer choices, and see which graph matches. That's all you have to do, is match the graph, okay? But algebraically, we do need to get common denominators, okay? So I can see here, you have to multiply the denominators by each other or by something to turn them into the same. So the 3 will have to get multiplied by 5, and the 5 will have to get multiplied by 3. And then the x's, this one has an x, this one has x squared. So we need another x over here to make it x squared. Now, what you multiply your denominator by, you have to also multiply your numerator by. So here on the left, we're multiplying by 5 over 5, and here on the right, we're multiplying by 3x over 3x. So that would be 20 over 15x squared. And then this would be 6x over 15x squared. So the whole point was we got a common denominator. So now we can add those together. It's all just over that common denominator of 15x squared. And I've got 20 plus 6x. Now, if you can simplify and reduce, you do that. Okay, up here in the numerator, I could take a GCF out, but I realized right away, even if I took out a GCF of 2, that's not going to give me a common factor with the denominator. So it's not really worth it. That's as far as I'm going to take it. Because even if I took out a 2, the 2 doesn't reduce with the 15, and what's left doesn't reduce with the x squared. So that's all I can do. Okay, but again, graphically, what you're looking for is that those are the same. Okay, so what you were originally given was 4 over 3x squared plus 2 over 5x. And then you would type in your answer choices. In this case, 20 plus 6x over 15x squared. Uh-oh. You look at that. Those did not come out exactly this. Oh, I have a cubed up here. It's 3x squared. I was like, did we make a mistake somewhere? Okay, now those are exactly the same. Y'all see that? So that's how you're checking in Desmos. All right, now if I want a common denominator in B, the first thing I'm going to do is factor out this 2. That's going to leave me with x minus 1. So I've got 2 times x minus 1 and a 4. Okay, well, I can turn this 2 into a 4 by multiplying by 2, but then this side still needs the x minus 1. So this side's going to get multiplied by x minus 1. And again, what you do to the denominator, you have to do to the numerator. Okay, so on this left side, it's 3 times 2, which is 6. And my new common denominator is 4 times x minus 1. Over here, 4 times x minus 1. But my numerator up here, I need to double distribute because I've got x plus 1 times x minus 1. Okay, so that's going to come out to x squared. That'll be minus x plus x, which will cancel, and then minus 1. So that's what I've got. I got my common denominator, so I'm ready to combine those numerators. So I've got 6 plus x squared minus 1. And then I combine like terms. So I've got 6 and minus 1. So I've got x squared plus 5. And that does not factor. So that's as far as I can take this. This is not going to reduce. If your numerator does factor, you'll want to factor it and see if you can reduce any further. That numerator does not factor. So that's all I can do. But again, you have a multiple choice test. You'll just type it in the way that it's written, type in your answer choices, and see which graph matches. All right, here I'm going to factor here on the right, this denominator. I'm going to take out a 3x squared, which will leave me with 2x plus 1. So I factored that. Now over here on the left, I've got the 3, that's good, and I've got x cubed, but I don't have the 2x plus 1. So this side has to get multiplied by 2x plus 1. Okay, and on this side, I have to get multiplied, that's x cubed. This one's only x squared, so I need one more x multiplied. So that's going to give me my common denominator of 3x cubed times 2x plus 1. And when I combine up here in my numerators, I got to distribute that 4. So that is 8x plus 4 plus, and then x times x is x squared. So I'm just going to rearrange that. That's x squared plus 8x plus 4. And I'm going to, in my numerator, and I'm going to see if I can factor that so that I'm going to maybe be able to reduce. So factors of 4 that would add to 8. Are there any factors of 4 that would add to 8? Just 4 and 1 and 2 and 2, right? Won't happen. So that's not factorable. So I can't take that any further. So that's as far as I can go. All right, now these next two, D and E, are subtraction. So they are slightly different because of that minus. We just have an extra step to be careful of when combining the numerators. Okay, so I first need to try and get a common denominator, but I gotta get these in factored form. So the factors of -8 that add to 2 would be +4 and -2. Okay, so this is my denominator on the left. This is my denominator on the right. They both have the x plus 4, so this side just needs the x minus 2. I don't need to change anything on the left, okay? So the numerator is just going to be 5x minus 1 minus, and then my numerator over here is going to be 6x minus 12. The extra step is right here for that minus, because everything over here needs to get the minus. So it's going to change the signs in that numerator. So we'll end up with 5x minus 1 minus 6x plus 12. Now this is all still over our common denominator that we got of x plus 4, x minus 2. Okay, now up here I'm going to combine like terms. So 5x minus 6x, that's negative x. Negative 1 plus 12 is plus 11. So there's no common factor to reduce. This is as far as I can take it. All right, the bell's probably going to ring here in a sec while I'm in the middle of E, but I'm going to finish this video. I'll stop the video after E and then start another one with the next section. Okay, but so here with E, we need to factor our denominator. Again, my pen stopped working, of course, especially when I'm in a time crunch. I'll be here in tutorials if y'all need to come, just for a place to sit and work, or if you want to ask questions about anything you've gone over so far. All right, y'all have a good one. See you tomorrow. All right, see if this pen will work now that I shook up that battery. Yep. All right, so I'm factoring the denominator on the left side here. Factors of, thank you, factors of 9 that add to 6 would be 3 and 3. Right, and then over here, I can factor this denominator as well because that's a difference of 2 squared. So it's going to be x plus 3 and x minus 3. Okay, so I've factored both of those and I'm looking to get them to be the same. I need a common denominator. They both have an x minus 3, but I need to get them exactly the same. So this side is going to need the x minus 3. And this side is going to need the other x plus 3 because there's 2 of them on the left. So we got to make sure there's 2 of them on the right. So then when I do that, in my numerator here on the left, I've got to double distribute. So that'll be x squared plus x minus 3x minus 3 minus, then this minus right here. Then I'm going to put parentheses. And then on the right side, that's just a 1 times x plus 3. That's just x plus 3. The 1 doesn't do anything. And my new common denominator is x plus 3, x plus 3, x minus 3. But now I've got to do that distributing of that minus. So that's going to be over here. I'll combine like terms here. So I've got x squared minus 2x minus 3, and then minus x, and then minus 3. All over the same common denominator. I'm not going to write it again because I'm going to do another step of simplifying. So when I combine like terms over here, I've got x squared minus 2x minus x is minus 3x, and minus 3 is negative 6. Okay, now I'm going to see if that will factor. All right, the factors of negative 6 that would add to negative 3 could be negative 6. No, I don't think that'll work. Let me double check. The only factors of 6 are 6 and 1, which would not give us 3, and 3 and 2, which would not give us 3. So that is not going to factor. So not factorable. So that's as far as we can take our numerator, and I'll put it over our common denominator. And that's as far as we can take it. And I will show you one last time confirming that in Desmos. So the original equation was x plus 1 over x squared plus 6x. I'm recording. You can come in. I'm almost done. Plus 6x plus 9 minus, and then that's 1 over x squared minus 9. So the way that it is originally written, and then what we got when we reduced it was x squared minus 3x minus 6 over, and then we got x plus 3 twice, and then x minus 3. So we can confirm here, those are the exact same graph. So even with those more complex ones, okay, your test is multiple choice, so you won't have to go through all this process if you don't want to. You can just check the answer choices to see which graph matches the original expression given. All right, I'm done. What's up?